This is our work GlucoMaker, enabling collaborative customization of glucose monitors. Diabetes is a health condition that impacts millions of people worldwide. These individuals use continuous glucose monitors to track their blood sugar levels. Research has demonstrated that individuals want to customize different aspects of their interactions with these devices. But individual needs vary, and it's difficult for off-the-shelf devices to be tailored to accommodate all of these requirements. Meet Alice, a 39-year-old living with type 1 diabetes. She works at a fashion design company, and so she prioritizes her overall appearance. She finds that her current off-the-shelf monitor is quite bulky and rigid. She also doesn't like the loud alarms that it forces, and she is constantly silencing her monitor during client meetings. Alice wishes her monitor could be more visually appealing and could give her more options over the type of feedback that it provides. She envisions a monitor that mimics a daily wear accessory that can minimize the attention that it draws to her. In our work, we consider end users like Alice. By considering them, we developed GlucoMaker, a system that can enable them to directly influence and design custom glucose monitors. Later in this presentation, we return to Alice to follow her journey as she uses GlucoMaker to design a custom glucose monitor in collaboration with a product designer and a healthcare professional. Current efforts towards diabetes management, the collaborative design of healthcare devices, and the prototyping of physical devices have highlighted three main takeaways. First, we have seen that device customization is a promising solution towards creating more personally relevant devices. Second, we know that collaboration between knowledgeable stakeholders and the end user is necessary to ensure that gathered requirements are accurate reflections of device user needs and preferences, while also ensuring that design devices are feasible and maintain the required functionality. And third, we know that end users can be encouraged to engage in the design process through do-it-yourself and self-authoring practices that use accessible and user-friendly interactions and tools. We use these three key takeaways to first perform a user study to gain insights towards what customizations are desired and how collaboration can support a customization design process, and to second, design and develop a tool, GlucoMaker, that introduces novel interactions that enable broader demographics of end users to engage in custom designing the physical aspects of their glucose monitors. To gain insights towards collaborative glucose monitor customization, we conducted a three-phase co-design study with adults with type 1 diabetes, product designers, and healthcare professionals. Through this study, we aim to understand what preferences end users have for their diabetes care technologies, how end users imagine these preferences translating onto their devices, and how customizations can be incorporated into devices, and how and where collaboration might support such a design process. In the first phase of our study, adults with type 1 diabetes, who we refer to as end users, completed a prototyping activity. Participants defined their personal preferences, prototyped a monitor using craft materials, considered the usability of their designs, and reflected on its ability to meet their needs. The second phase of our study engaged product designers and healthcare professionals. Participants reviewed end-user proposed designs and discussed any questions or concerns that they had. This helped us understand what types of conversations might take place during the design process. In the last phase, all user groups participated in a focus group session where we revisited designs to understand how conversations could occur and had a discussion regarding the use cases for collaboration in this context. We had 12 participants and collected activity workbooks and audio and video session recordings. We analyzed our data using deductive coding, and we looked for evidence towards two higher-level concepts, collaboration and customization. We organized our results into two categories, customization and the collaborative design process. These are some example prototypes designed by our participants. All our end-user participants expressed a desire to have more customized devices that better suit them and their needs. They were most interested in performing software customizations related to data collection, management, and visualization, and physical customizations related to how and where devices are worn. Through our focus group discussions, we also found that our participants discussed a collaboration process similar to a previously proposed model by researchers in healthcare. This process followed a user-driven model where each stage varied in its level of involvement and collaboration. We also identified a set of 5 design goals for a collaborative tool to support the design of customized glucose monitors. These 5 design goals reflect discussions our participants had and inform the design of our collaborative system, GlucoMaker. This is GlucoMaker. GlucoMaker is a tool that supports end users in designing custom glucose monitors in collaboration with relevant stakeholders. It's hosted as a web application and it contains 5 main components: the customization guidance interface, the device designer interface, the collaborative discussion interface, the learning portal feature, and the project overview. The customization guidance interface allows end users to independently begin their ideation phase by selecting their preferences related to where their monitor is worn, what form it takes, and how it provides feedback. The device designer interface is a 3D editor where users can create and edit device design models. GlucoMaker currently supports 3 workflows with varied levels of support and flexibility for a broader demographic of end users. The first workflow provides predefined models and only allows users to perform minor edits to an existing model, and the second and third workflows provide an empty modeling space. The second workflow allows users to import existing 3D models and build over top of them, while the third workflow allows users to build their model entirely from scratch using basic 3D shapes. The collaborative discussion interface allows all user groups to have discussions about the design using digital sticky notes. The use of sticky notes allows for spatial associations and for the grouping of conversations into relevant pockets. The learning portal allows users to access learning resources to support their design and fabrication processes. In the future, this can also be expanded to include a database of user-created projects to serve as inspiration or starting points. Lastly, the project overview provides a high-level summary about the project and its current status to all collaborators. Using these 5 components, end users can design their own glucose monitors by selecting their preferences and adapting or creating a unique monitor design with CAD software-style edits. They can discuss their designs with stakeholders to receive relevant feedback and design suggestions, and they can develop and apply their technical knowledge towards the physical construction of their custom glucose monitors. Now that we know what GlucoMaker is and what it offers, let's return to Alice. As I previously mentioned, she has a set of preferences for how her device should look and function. Alice begins her design process by logging into GlucoMaker and selecting her preferences. Given her desire for a daily wear accessory device, she considers designing a pendant. Seeing that as an option in GlucoMaker, she makes her selections accordingly using the customization guidance interface and generates her model. On the next screen, the device designer, she is shown a pre-made pendant model. Here, she performs slight edits like changing the size and color of her pendant. She also uses the collaborative discussion interface to add notes with comments and questions for her stakeholders. Once satisfied, she shares her design. Once shared, stakeholders gain access to the design. Here they can respond to questions, alter the model as needed, and similarly share and approve it once satisfied. Once all 3 parties have approved the design, the product designer can begin fabricating it. To do so, they export the model, laser cut it, build out the circuitry, program the model, and attach all the pieces onto an enclosed monitor. Once complete and functional, the monitor is sent back to Alice for use and testing. Before conducting a user study to evaluate the usability of GlucoMaker in practice, we first conducted an evaluation by demonstration. We developed 3 example monitors, shown in this table, that highlight different workflows and features that GlucoMaker supports, as well as different potential monitor characteristics as they relate to our user study findings towards customization interests. The pendant that we saw Alice design was our first example. Our second example is an audio, light, and numerical reading purse. This example serves to primarily highlight the need for collaboration when designing. For example, while a purse might be highly desirable to an end user, a healthcare professional might quickly point out its potential issues, such as not always being worn on the body and being an easier accessory to lose or have stolen. Our third example is a vibrating hair clip. This example was inspired by our most unique participant-proposed design. We conclude our paper with a discussion about the levels of users that GlucoMaker supports. We ground our discussion using Saunders' levels of creativity and we reflect on how GlucoMaker supports users with different motivations, goals, comfort levels, and expertise. For example, as previously discussed, one of GlucoMaker's main features is the device designer. In order to support a broader demographic of users, we include 3 designer workflows. The first is for predefined models, and the second and third are for custom models. The inclusion of these 3 workflows introduces many options for end users to engage with models, such as different levels of flexibility and different levels of required knowledge and creativity. In the predefined workflow, users are provided with a predefined model based on their selected preferences, and they can edit details such as its size and color. In the custom workflow, users have more flexibility to either build a model from scratch or upload an existing model to build over top of. Individuals might have different motivating factors behind their desire for customization, or they might have varied levels of knowledge or access that influence which of the provided workflows they are able to effectively engage with. In conclusion, in this work, we conducted a user study to gain insights towards what customization preferences end users have and how collaboration can support a user-driven custom design process. We developed an interactive system, GlucoMaker, that enables end users to custom design more personally relevant glucose monitors in collaboration with relevant stakeholders. And we conducted an evaluation by demonstration to highlight the breadth of custom monitors that can be designed using GlucoMaker and the diverse demographic of users that GlucoMaker supports. Thank you.